how to make money in aerospace business.
You need to have good, reliable vacuum induction melting furnace.
Okay, so how about vacuum induction melting of turbine blades? This is in today's episode. In melting turbine blades, there are several factors important. What are the most critical for your customers?
Most critical factors for our customers is good vacuum, quick melting time, and fast casting.
Okay, so Michał, let's see step by step each parameter.
Okay, let's go.
Michał, why we need here vacuum during melting?
Vacuum during melting is needed to be sure that melted material, nickel-based alloys, do not get oxygen
To protect the surface.
to protect the blade's surface.
So what vacuum level do we need?
For operation, we need at least 10 to minus 3.
Okay.
That's why we are using diffusion pump.
And supporting system, mechanical and root.
Yeah, that's right. Mechanical and root is a supporting system. And after we reach 10 to minus 3, diffusion pump starts and is keeping the loads of gases from the material outside of the furnace.
You mentioned about second important factor, heating time or melting time. How it works?
We have to have good power supply. For this kind of furnace, it's 175 kilowatt.
Okay. Heating by induction, like the name.
Yes,
of
that's
the
right.
furnace.
Heating by induction. And we have the melting coil here. As you can probably see, the melting coil is built and prepared for the load to be melted inside. There is a coil,
Okay.
from oxygen-free copper, and thanks to that, the power supply gives us induction field to heat up the material that will be
Okay.
inside.
Just for better imagination, standard power of such element, heating power.
The heating power, standard heating power for this size of furnace is 175 kilowatt. It
And-
melts 50 kilograms in about 15 minutes.
And when you mention about time, it's critical. Approximately, what is the time
Time
of
for
melting?
Melting is 15 minutes.
15 minutes. Perfect. Michał, I can imagine that we already melted the material inside, and then we have to do casting.
Yes.
How to do it? Can you show us?
For the casting, we use a special joystick.
Okay.
This moves.
But this is okay for moving. But first of all, we can see how the melting material looks like here.
Yes, the material is melted. You see that it's fully melted. On HMI, you see the temperature.
Okay.
And then when the material is melted, operator can smoothly turn joystick and pour the material fast into the mold.
Why it's so important to make it by the operator?
Operator can see the melt box and see if there is no splashes, if the whole material gets into the mold. And this move is recorded by our system.
Okay.
And if there are operators that are young and not very skilled, they just push the button and repeat the same process automatically without moving the joystick.
So you can do it like in airplane, yes?
Yes, that's
Or
right.
autopilot or manually.
Yes, that's right. This is the feature that is very important, because if you have good movement of the melt box, it pours everything without spilling. It's recorded, and then each time the process is repeated. In aerospace business, the repeatability of the process is very important. So each time you have the same results as the first time.
I understand we already finished the melting process. Yes, or casting.
Yes.
And what's next?
The next step, when you take out the ready mold, you have the blades, but you need to do the process of heat treatment to be absolutely sure that they are good for the aircraft engines.
This is more familiar for me. I mean, heat treatment. in a vacuum. So it means there is many times the combination of vacuum induction melting for melting the blades, but then there is necessary the heat treatment also in the vacuum to not lose the quality of the component.
Yes, that is right.
Thank you for watching us today and see you in the next SECO Talks episode.